Today we are going to look at trig functions for general angles. So we are just still looking at these trig functions, sine, cosine, tangent, cosecant, secant, and cotangent. Okay, and today we're kind of looking at where it would be graphically, including theta. So you can find the values of trig functions for angles greater than 90 degrees or less than 0. Okay, so if it's greater than 90 degrees over to that obtuse angle there, you can find those, as well as if it is negative where you're rotating clockwise instead of counterclockwise. So let theta be an angle in standard position, and let P, that point, be x comma y, be a point on the terminal side. So using the Pythagorean theorem, we can find this r value by taking the square root of x squared plus y squared. Then the six trig functions of theta are defined below. So we do just have sine, cosine, tangent, everything else laid out in terms of x, y, and r. So x and y are going to be the point you're given. Okay, those are your x and y values. So for sine, you take that y value from P over the r value you find after using the Pythagorean theorem. Okay, same thing with cosine. Take your x from your original point, and then after you find r using the Pythagorean theorem, you can set up that ratio. Okay, so that's all we're going to do today. So in example 1, we have the terminal side of theta in standard position contains the point -6, 2. We want to find the exact values of the 6 trig functions of theta. Okay, so our point at -6, 2, we have our x and our y already. Okay, and what we want to do is find r. So to find r, I'm going to use the Pythagorean theorem right here. Okay, so we have r is equal to the square root of x squared plus y squared. And I can just plug in x from my coordinate point here of -6. Okay, so we have -6 squared plus y squared is, well, y is 2. So we have 2 squared. And we just want to simplify that. So we would have the square root of 36 plus 4. Which is the square root of 40. And I am going to simplify this radical. Okay, so 40, or the square root of 40, can be split into the square root of 4 and the square root of 10. Since I have 4 times 10, that's 40, right? I can take the square root of 4. That's 2. And then I still have the square root of 10. So this simplifies to 2 square roots of 10. And that is your r value. My x value, again, is just -6, and y is 2. So using those 3 values, I can find the 6 trig functions from theta. Okay, so I have sine of theta. That is equal to y over r. So I'll take our y value of 2 over r. Okay, if I have 2 over 2, what happens? They cancel. So I have 1 over a square root of 10. Now I don't want that radical in the denominator, so how do I simplify that? Good. Okay, so I'll multiply by square root of 10 over square root of 10 to get the square root of 10 over 10 as that ratio. Okay, so we'll do the same thing with cosine of theta. Cosine of theta is x over r. So I'll take our x value of -6 over r is 2 square roots of 10. Okay, I can simplify this right here. If I have negative 6 divided by 2, that's a negative 3, and that's still over square root of 10. Again, I want to simplify that, so I'll multiply by square root of 10 over square root of 10 to get the radical out of the denominator. We have negative 3 square roots of 10 over 10. Okay, and then tangent of theta is y over x. So our y value is 2 over our x value is negative 6. Okay, I can simplify that fraction to negative 1/3. Okay, then I have the reciprocal trig functions as well. So we have cosecant of theta. I'm just going to take this reduced form I found right here of 1 over square root of 10, take that reciprocal, you end up with just the square root of 10. You can write it as the square root of 10 over 1 if you'd like. Okay, and I don't need to reduce that at all. Same thing with secant of theta. Take your reduced form right here, take that reciprocal, so flip-flop the numerator and denominator. So you get the square root of 10 over negative 3. Okay, I don't have the radical in the denominator, so I don't need to simplify anything. And then cotangent is the reciprocal of tangent. So flip-flop, again, your numerator and denominator. Either negative 3 or negative 3 over 1 is acceptable as well. Okay, so we're still just finding these 6 trig functions given x, y, and r now. Okay, questions on example 1? Make sense? All right, so at the bottom, you have if the terminal side of angle theta in standard position lies on the x or y axis, the angle is called a quadrantal angle. Okay, so those angles are 0 degrees, 90 degrees, 180 degrees, and 270 degrees, or 360, which is also the same as 0. So that's when your angle lies on the x-axis here, the y-axis here for 90 degrees, 180, again back to the x-axis over here, and then 270 is the y-axis down here. Okay, so that's when your angle lies on an axis. Now when that happens, you will have some undefined trig functions. Okay, you will have some undefined trig functions where it can't have a 0 in the denominator. So that's what we're going to do on the back. So again, it's the same process that we did on the front. So in example 2, the terminal side of theta in standard position contains the point negative 2, 0. Okay, so those are your x and y values. So I need to find the r value. So again, to find r, take the square root x squared plus y squared. Okay, so we have the square root of negative 2 squared plus 0 squared. Okay, negative 2 squared is 4. So I have the square root of 4, which is equal to 2. Okay, so my r value is equal to 2, x is equal to negative 2, and y is equal to 0. So I can use those to find my 6 trig functions from theta. So the first one we have is sine. Okay, sine of theta is y over r. Okay, so I have my y value is 0 over my r value is 2. If I have 0 over any number, that's 0. Okay, cosine of theta is x over r. So I have negative 2 over 2, which is negative 1. Tangent of theta is y over x. Okay, y is 0, x is negative 2. Again, 0 over any number is 0. Next, we'll do our reciprocals. So we have cosecant of theta. So I'm going to take that reciprocal of sine. So I have 0 over 2. So that reciprocal would be 2 over 0. Now, I can't divide by a 0. Okay, 0 cannot be in your denominator. If that happens, that would be undefined. Okay, so if you end up with a 0 in your denominator, cosecant of theta in this case would be undefined. Okay, next we have secant of theta. That's the reciprocal of cosine. Okay, so we'll have 2 over negative 2, which again is still just negative 1. And then cotangent of theta, reciprocal of tangent. So flip your numerator and denominator. Negative 2 over 0, which would be what? Undefined. Okay, so we just have to solve for r, then we just have to write out those 6 trig functions from theta. Now, when we're doing this, this is when your angle theta is greater than 90, okay? So it's greater than 90, or it's less than 0. Okay, so if you think about it graphically, like the one on the front here, okay, that point was at negative 6, 2. Okay, negative 6 is over here. 2 is right here. So your point would be right here, right? So your theta angle would be obtuse. So that is greater than 90. So your 90-degree angle would be right here. And normally, when we were dealing with sine, cosine, tangent before, our triangles were within this quadrant right here. So when we're doing this r value, it's in these 3 quadrants right here. Okay? So that's why we use that r instead of just using opposite and adjacent. Okay, questions? No. I just wanted to show you where that was.